In this video, we will learn about canonical LR parsing. To that end, we will first create LR1 Automaton for our example context-free grammar, and then we will create CLR parsing table. The algorithm to use that parsing table and create parse tree has been already discussed in a previous video, because CLR parsing algorithm is same as SLR parsing algorithm that we have learned previously. So let's start with this context-free grammar. Our first step is to augment this context-free grammar with a new starting symbol S bar. So we write here S bar. S bar should point to the previous starting symbol S. So this is our augmented context-free grammar. We should also number the productions of this context-free grammar, because these numbers will be useful to add reduce instructions in our parsing table. So I number this as 0 production, this as first production, second production and third production. So now our grammar is augmented and its productions are numbered. Now we will start with the creation of LR1 Automaton. Recall that SLR and LR0 parsers use LR0 Automaton, whereas CLR and LR that we will discuss in next video both use LR1 Automaton that we are going to create here. So first we take this new production that we have introduced recently in our augmented grammar and create our start state with this production. S bar goes to S and we add dot here. In LR1 Automaton, each production has look at symbol attached with it. That's why it is called LR1 Automaton, because it has one look ahead symbol attached with each production. The rule is that for our starting production, that means S bar goes to dot S, our look ahead symbol is always $sign. This $sign is end of input marker. So we are done with our first production of the first state of automaton. So this will be my starting state of LR1 Automaton. But I have to add more productions here. I'm not done with this state. Now because there is a dot before a non-terminal, so I have to add all the productions of S here, and the dot will be at the beginning of the right hand side. So I will add here S goes to dot XS. Now what will be my look ahead? So the rule of adding look ahead is that I have added this production because of this S. So I will take whatever is after this S, that means in this case I have $sign, and compute first of that which is after S. So I will compute first of $sign, and whatever my result is, I add that result here. So $sign is although a special symbol marking the end of my input, but first of $sign is equals to $sign. So it is equals to $sign. So I will treat $sign as my terminal. So here I will add $sign as look ahead. Now look carefully, because now the thing is going to be more interesting. So now I have to add productions because of this X as the dot is before a non-terminal. So I will add all the projections of x because of this x. I will add here x goes to dot ax and x goes to dot b. And because I have add these projections because of this x, so I will compute first of whatever is after this x. So I will compute first of x and $sign, because after this x I have this x and $sign. Please ignore comma, as comma is neither a terminal nor a non-terminal. It is for the separation of projections and look ahead. So please ignore comma. So first of x and $sign is equals to first of x union, and this union is conditional. We will have a union here if x drives to empty string, and then I will say first of $sign. So in case first of x has empty string, then I also have to include first of $sign. Otherwise, I don't have to compute first of $sign. So in this case, first of x and $sign is equals to, now first of x is equals to a comma b, and because this set does not have empty string in it, so I don't have to compute first of $sign. So that's my answer of first of x and $sign. I will add here these terminals as my look ahead. Once again, because it is LR1, so I will add these terminals with OR symbol because they both represent one look ahead. Similarly, in this case, I will add A or B. Their order does not matter. So I'm done with the start state of my LR1 automaton. Now, using the Goto rule, I have to create transitions from my start state. I will have a transition from my start state based upon this S, because dot is before S. So when I will see S, I will move this dot to the right hand side of S. So I will have transition based upon this S. Similarly, I have transition based upon this X. I will have transition based upon A, and I have transition based upon B. Now let's create more states. So when I see S, then this dot will move towards right of S. I will get S bar goes to S dot. And this look ahead will be added here as it is. So I will have here look ahead of $sign. And now because after this dot there is no non-terminal, so I will not add any more projections here. I'm done with this state. Now I have to add another state here based upon X. So when I see X, then this dot will move towards right of this X. I will get S goes to X dot X. I will add look ahead symbol as it is. But now I have to add more projections here because after this dot I have a non-terminal. So I have to add all the projections of X here. This is based upon the CLR rule. So I will add here X goes to dot AX and X goes to dot B, because these two projections are added here because of this X. After this X I have $sign. I will add here first of $sign, and I will add here first of $sign, and we know that first of $sign is equals to $sign. So basically I have to add here $sign as my look ahead. $sign. And now because after my dot there are terminals, so I will not add any more projections here. and I'm done with this state. Now I have to create a new state based upon this B. When I see B, then my dot will move to the right of B, so I will get X goes to B dot, and I will add look ahead as it is, A or B, and I'm done with this state because after B there is no non-terminal. Similarly, when I see A, then this dot will move, I will get X goes to A dot X, I will add look ahead A or B as it is, but I'm not done with this state because after dot I have a non-terminal. So I have to add all the projections of that non-terminal here. I will add X goes to dot AX, I will add X goes to dot B. Now because I have added these projections because of this X, so after this X I have these two terminals. So I will add here first of A, and this OR is translated into union. So I will say union first of B, and first of A, because A is a terminal, so it will be equals to A, union first of B, B is also a terminal, it will be equals to B. So I will add here A or B. I will add here A or B as my look ahead symbols. I am done with this state. So we will continue in the same manner and create more states. From here I can't create any more state because my dot is at the end of projection. From here I can create more states. So one state is that I move dot to the right of X. So I will create a transition on X. Here I will create transition on A, and here I will create transition on B. So based upon X, I will have S goes to X, X dot. This dot has moved to the right of this X. And I will add look ahead $sign as it is. And because the dot is at the end of projection and there is no non-terminal after this dot, so I will not add any more projections here. I'm done with this state. Now I have to add another state based upon this A. So I will have X goes to A dot X followed by $sign as my look ahead. Now please note that if I would have been creating LR1 Automaton, then this state and this state would have been same because they have same source productions. X goes to A dot X, and here also we have X goes to A dot X, and the other two productions will be also the same. But in this case, because of this look ahead, these two productions are not considered same. I have to create a new state here because X goes to A dot X $sign is not same as X goes to A dot X A or B. Because of the look ahead, I will have two different states. So here I will create two more predictions. Because of this X, I will have X goes to dot AX and X goes to dot B, and I have to add look ahead whatever I have after this X, which is $sign. So I will have here $sign because first of $sign is $sign. I will have $sign here. So I'm done with this state. But this state already exists here. So I will not create this state again. I will on B, I will just point to this existing state. So I will point to this state on B. I will not create a new state. And now I am done with my LR1 automaton, but I should also number all of my states. Let's number this state as 0 and this state as 1, this state as 2, 3, 4, this is 5, 6, let's say 7, 8, 9. So I have 10 states starting from 0 and last state is my state 9. So I have 10 different states. Now next step is that I will create my predictive parsing table. In our predictive parsing table, we have 3 different sections. We have state sections here, we have actions, and we have Goto. In the states, we will mention all the states. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are my states. In the action, I will mention all the terminals and end of input marker $. So I have terminals A, B, so I have A, B and end of input marker $. In the action part, and in the Goto part I will mention all the non-terminals. So my non-terminals are S and X. So I will write here S and X. I will not write S bar, which is a special non-terminal which I have introduced while augmented my grammar. I will not write S bar here. Now I have to add shift, reduce actions and Goto in my table. Adding of shift and Goto is exactly the same as was in CLR table. So I will add shift and Goto based upon these transitions. So let's add those actions quickly. So from this state, on S I go to 1. So that means from 0 I go to 1 state on S. Therefore, on the 0th state I will add 1 on grammar symbol S. From 0 state I go to state 2 on X. Therefore, on the 0th row I will add 2 below X. These are my Goto actions. From state 0 on input symbol A, I go to state 4. So I will add here S4, and because on B I go to 3, so I will add here S3. I'm done with my first row. So on state 1 I don't go to anywhere, but this is a special state, and because this is a special protection that S bar goes to previous start symbol dot, and here I will add a special state which we call acceptance state on the input symbol $. So I will mention here except, because on 1 when I see input symbol $, I go to this special state which is my final state of this automaton. Similarly, I will add all the shift and Goto actions in this table. Let me quickly fill this table and then we will skip to the reduce actions. So I have added all the Goto and shift actions in my table. Now I have to add reduce actions. For reduce actions, these look ahead will be important. Otherwise, this look ahead will be ignored when adding shift or Goto. So let's find all the protections that can be used for the reduce actions. The reduce protections are the one where the dot is at the end of the protection. So here I have a reduce production because dot is at the end, but this is a special production. I will ignore it. I will not reduce on this because I've already added except based upon this. This is a reduced production. So let me mark all the reduced production where the dot is at the end. Here I don't have any reduced production. This is a 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 reduced production. Okay, and that's it. So these are my reduced productions. So let's add reduced sections based upon all of those productions that I have marked. So we can start from anywhere. Let's start from here. So I have to add in at $sign in state 5 this production. This production has a number and the number is 1. So on the 5th state at $sign I add R1. Now I have to add this production in state 7 on $sign. And this production has a number. This is third production. So I will add in state 7 here R3. I'm done with this production. I have to add this production in state 8 at the $sign. The number of this production is 2. So I will add here R2. Now this is interesting because it has two look ahead symbols. So here I will add this production on both A and B, and this production number is 2 and the state number is 9. So I will add here R2 on A and R2 on B in state 9. I'm done with this. Now for this is production number 3 and the state number is also 3. So in state 3 I will add R3 on both A and B symbols. So I will add here R3, R3. And that's it. So this is my final predictive parsing table for CLR, and I can use this table to run my algorithm that we have already seen previously while discussing SLR. So that's it for this video. In the next video we will learn about LR, that how to make this table more precise, because here the number of states are much more as compared to SLR, because although these two states are the same in terms of productions, but we have created two different states because of look ahead. Similarly, these two states are the same in terms of productions, but we have treated them separately because they had different look ahead symbols. In LR, we will combine those states into one state. So let's see that in the next video. Stay tuned.